Okay, I just finished reattaching the speaker and the yoke. Clear some room here and remount the picture tube, which is going to be a little tricky because I do not have the mounting hardware for the yoke. Also didn't have an ion trap magnet for the CRT, so I dug this one up, and I hope it'll work. I think this only needs a single magnet. Oh, this is curious. Ooh, I've got the bases loose on this too, so I'm wiggling this thing. Break it off. That sure looks to me like a straight gun. Usually, the ones with an iron trap magnet, the cathode down in here, it's at a, you can tell there's an angle. It's kind of cut like this. This one isn't. It's a slight bend of the gun overall, kind of like this, but it's not that extreme. So when this was rebuilt, they may have used a straight gun. Well, what I'm going to do right now is I'm going to wrap some electrical tape around that base because I don't want to damage it by wiggling it. And then I'll find something, some towels or whatever, to kind of prop it up and hold it in place. Same goes for the yoke. First try this without the magnet. At least see that the set powers up, see if we get some sound, and I can see if there's any high voltage. Also, the set does... Okay, there is some coding. Yeah, the set doesn't have a high voltage filter cap. Relies entirely on the CRT's coating to filter it, and I don't have the ground strap or anything hooked up on that. Well, that's okay. I can rig something up later with some aluminum foil and tape or something. I'm gonna braid over to copper. In other words, it'll work without the filter. It just won't work as well. So, smooth through here. See, this is the downside to adding tape. Yeah, it's a quick and dirty way to hold the base on, but then when you try to get the yoke on, it gets hung up on the added thickness of the tape. It's electrostatic focus, so no focus coiling to worry about. This one wire here is green wire. A bit short, but it's okay. I'm not sure exactly how far back in the CRT should be in the set. Here's the little connector. And it came with this metal ring on it. I don't know if it's supposed to be there or not. Oh, looks like I was soldered onto one of these at some point and it broke loose. So this is a discount set, so there's no suction cup or anything, by the way. You see the graphite coating on the CRT is wearing off of my hands. I do have some slip plates so I can recoat it if need be. See that metal ring floating around. Oh, so let's see the yoke. I guess it's not bumping into anything, and it's pretty much up against the front of the CRT, so I guess I'll just stay like that. What I'll end up doing when I get the set working is I'll make up a cardboard tube. Maybe I can find a paper towel roll or something that's the right diameter and slide it in there between the yoke and the glass to give it some kind of hold it in place, because right now there's just nothing holding it in there. I did find a channel knob and fine-tuning that fit. I'll show them later. I don't want to rotate the set right now, so I can change the channel. Did not find one yet for the volume or power, but I'll do them manually. It's easy enough to turn them. Alright, so we need a power cord. Got some cheater cords hanging up on the wall. I already checked the stud for continuity once I put the tubes in, and I do have continuity. I might turn the power switch. pt3o4. Got my high voltage probe here handy. Alright, here goes. Trying amp and 1.1 amps. Tubes are lit up. High voltage will make a god awful horrible sound. And no high voltage. Turn this off. I was told by a serviceman who had worked in these in the past that they make a really unique sound when you turn them off, and I think that's what we just heard. So there's something drastically wrong in the high voltage box. I studied the wiring on the yoke really carefully, and I didn't see anything wrong with it. Now I kind of regret putting this cover back on because I can't see the fly back. I'll try to take another gander. Yeah, I don't know. It sounds like there's a dead short somewhere in there. Alright, so I was kind of hoping to get something more than that off the first power up, but apparently not. I'm going to try powering this up again with the cap off that, see if we can get some sound out of this. His side of the speaker. It's responding when I turn the channel. That's good. Some tunings have a limited effect. At least less than I expected, but yeah, sound. Well, that's a good sign. I think the tuner's working. That's it sound again. So now I need to troubleshoot this. I checked the flyback for resistance. It was good, but I didn't actually do a ringing test on it. Then again, it's this, which, well, I guess there's, I don't know. Uses a thicker gauge wire. If there was a shorted turn, because there weren't that many turns, I would expect it to throw the resistance reading off. But alright, well, the SAM service info, it's got resistance charts, voltage chart probably, but I'll start with the resistance chart. So typically it's the resistance between each pin on the tube and the chassis. I'll start with horizontal output tube and damper tube and see what I get. I checked the yoke wiring and I popped the cover off the flyback, re-examined that wiring, everything looked a-okay. So I moved on to the resistance chart, starting with the 17DQ6 output tube. Some of these pins aren't used, so the first one that was, pin 2, is part of the filament, so that was fine. Then I moved on to this guy, should be 8200 ohms. And that little symbol there indicates that it should be red. from the output of M2, which is actually a diode. It's D2, which is this guy. So basically right off the power supply, so right to this point. Well, if you trace it around, it's actually this guy here. So it's getting its power for the tube through that 8200 ohm 7 watt resistor, which is this guy, and I just checked it, it's dead open. That's why I really hate these old power resistors. I'm starting to think that I should just shotgun them whenever possible. If you recall, in the Dumont I just restored, I had some open power resistors in that as well, and plenty of my other sets for that matter. I think what happens is this cement type material, and same goes with these, I think they sort of promote corrosion of the copper connections inside. Now another possibility is that there's something else wrong here and there was so much power going through that it fried, but I didn't have this on very long and it was making that funky sound immediately on first power up. So I'm gonna say that it's just a bad resistor. So now the question is, do I have an 8200 ohm 7 watt or better resistor on hand? I don't know, but I suspect I can combine some and cobble something together. Well, for once I got lucky. 8200 ohm 10 watt, nice vitreous enamel resistor. Alright, so pop that guy in there, and I gotta hook everything back up, and let's give it another try. Or maybe I'll give it a try without the CRT in place. I'll just use a dummy load for the resistor and see if we get some high voltage, and I'll put it all back together if we do. I've always been curious to see what exactly is inside these cement type power resistors, so got out a pair of pliers, just started nipping away at it, and I was able to get it open. Not too much trouble. And I noticed that there are some really thin wire fibers sticking out there. Now, I may very well have damaged that while I was extracting it. I'm not sure, but I guess we can try hooking up a meter at one end and see if I get continuity. Going throughout it at any point. Yeah, I do. Sliding it along the body. It looks like I lose continuity right about where those fibers are sticking out. So, hard to say. I mean, obviously it was measuring open, so I guess that, you know, something happened to it, but it's not corroded like I thought it might be. And the break is sort of here, it's not at like one end from corrosion, so it kind of does make me wonder if it might have been too much current going through it. So, well, if it does, I may very well end up frying this one. I guess there's only one way to find out. Alright, let's give this another try. I'm going to leave the high voltage cage off, and I got the speaker disconnected. I want to be able to get in and see what's going on down in here. I also got a high voltage probe handy. Could use my fluke, but it's easier just to grab one of these and then to hook up that fluke adapter. So I'm going to position this high voltage lead so it's not brush up against anything. Alright, here we go. Tubes are lighting up. No crazy sound like before. There it is. Damn. The new resistor's barely warm. Try that again and take a closer look at what's going on. I think it's coming from the flyback. There's also blue glow on the output tube, but it's on the side of the glass, which usually is not a problem with these. So I'm kind of leaning towards that other resistor did burn out, because there's something else still wrong. So the investigation will continue. I popped the plate cap off the horizontal output tube so I could run the set without frying anything. And I hooked up a scope. So here's what I've got. It's a signal that's about 100 volts peak to peak. Kind of a square wave with a burst of oscillations periodically. And here, and then the rest of the time it's just high. Well, that's not what it's supposed to look like. It should look like that. Amplitude's about right, 90 volts peak to peak, but it should be a sawtooth all the time. And they say the frequency is 7875, but I think that means with the image like they have on that screen, it's got to be 15.75 kilohertz. That's standard NTSC frequency. So it turns out that this frequency, I've got my cursor set up there, is about 20 kilohertz. So too high, but it's in the ballpark of the horizontal oscillator frequency. This frequency, the big square wave, is like 136 hertz. So that's way, way, way wrong. So it looks like it starts oscillating and then something kills it for a while, then it starts oscillating again. I have not seen that before. If I work my way back from here, we end up in the horizontal oscillator. There's two controls that can be manipulated, the horizontal hold and horizontal waveform. Horizontal hold is this control, and horizontal waveform is the one that I glued back together down here. The horizontal hold I've already tried tweaking. Really doesn't do much of anything, and I wouldn't expect it to, because I don't think it does much when there's not an incoming signal. So let's try the horizontal waveform. Oh, it's quite the right size. There's a slug in there with the hex interior. It's kind of rotating now. See if it's actually doing anything. Yeah, it is, actually. I can change the frequency. So it's higher now? Lower. So that's right. And now it's clipping off at the top. Oh, what? Hey, it's, I think, looks like the periods of oscillation are getting wider and wider. So, and it's backing off. It's better. And it's kind of a clipped sawtooth like it's supposed to be. So now why isn't it oscillating all the time? I will continue to investigate and check the components in the horizontal oscillator circuit. I've been troubleshooting this set for a while now, and still no smoking gun, but I'll tell you what I've discovered so far. First off, that is the 6U8 horizontal oscillator tube down in there. It's a two-section tube. One half is used for second video IF, and then there's a triode in there that's used for the horizontal oscillator. Pretty simple circuit, just one tube. Well, I checked the components around it, and there aren't too many, but there's one mica cap, so I immediately thought, hey, maybe it's a bad mica cap. No, it checks out fine. So I then started checking the voltages and signals that are on there. The voltages are off a bit. Pin 1 was in the ballpark. Pin 9 is more like negative 20 volts rather than negative 45. And right now I'm checking the waveform right here, which should be this distinct kind of shape. You see this in a lot of early sets. That's what this coil down here is for, the wave shape. You're supposed to tweak it So the waveform looks like that, where it's got a rise, a bit of a hump, drops back down, and a little peak before it goes sharply negative. Well, I sort of have the right shape, but it's got that same wackiness where it works okay for a while, and then it goes nuts. And by adjusting the horizontal wave shape and horizontal hold, I can get I can vary the length of time when the waveform is more or less stable before it freaks out. And this is about the best I've gotten so far. It should be just like this continuously and fairly stable. So, been working my way back, but these waveforms like here, that's for the incoming signal. It picks it off and uses this diode here. It's a sync amplifier and then sync separator. Well, if there's no incoming signal, the set should still have a raster, and you should see snow on the screen. So it seems to me that even if there is something screwed up over here, so what? Like if this diode's bad, but I've heard plenty of guys say that these early germanium diodes can go bad in these sets. So what the heck? I'll figure I might as well try that. And I also hooked up a good strong signal source, my VA62, so I should have a good strong sync pulse coming through. So let's check cathode side. So now we're looking right here. That's where the signal comes out of the sync amp. And it is rock solid. Should be about 20 volts peak to peak, which 1, 2, 3, 4, 5. Actually, I have moved a little bit more than that. But I'm driving the signal really hard. I can drop it down a little. But notice when I drop the signal level down, it starts to get a little unstable. So I kind of figured I'd just keep it cranked up. Regardless, though, what's on the other side is what I wanted to show you, which is nothing whatsoever, or just some noise. I mean, there's certainly no good signal getting through. It should look like that, actually be even a stronger signal, 30 volts peak to peak, instead of a spike, be more of a sawtooth. So, I don't think that diode's bad. Now, 1N60s, I've looked around a few times. They haven't been made in a long time. They are not available unless you find some new old stock. Possibly a Schottky diode could work, or possibly a 1N34, which is also an old germanium type, which is still more or less available. It's popular in crystal sets, guys who roll their own radios. So I do have a little supply of diodes on hand. Some of these are newish ones, but I got some old ones. There's an ancient Philco. How about this really old school copper oxide rectifier? I don't want that. Western Electric from '58. Don't know if I have any 1N60s. It's probably a 1N34. It just says 3-4, but that's probably what it is. There's a 1N64. Might be good enough. 1N72. The reason why germanium has a smaller voltage drop, like 0.3 volts or 0.4 volts versus silicon, which is 0.7. I don't know if it matters much in this particular application. Actually, I think these are all 1N34s in here. I don't recall ordering some, but that's sure what they look like. And I know I also have a bunch of small silicon diodes, small switching ones like 1N914s or 1N4148s, which might also work in this application. I think the simplest thing to do is just try them and see what happens. 1N93? No, 1N936. No idea what that is, but certainly old. I removed the original green diode. I noticed it was slightly warm when I took it out, which sure doesn't seem right. Let's try to test it. I've got my Fluke 27 in continuity, which is also a diode testing mode. That's something I use too often. Alright, well, got it going one way, nothing. Let's try it the other way. Nothing. It doesn't look good. I'll try one of these mystery diodes. There's some faint markings on them, but I can't clearly make out any number on them. But this sure looks like a modern package. So it's probably something I ordered. And if I ordered them, I probably ordered 1N34s. Nothing that way. Alright, that way. That number, I assume, is the voltage drop across it. And 0.26 would sure be germanium. Just by way of comparison, here's a 1N4007 silicon power diode. So, yeah, 0.54 voltage drop in the other way. Alright, so we'll give this a try. Now, I assume this is testing them with a pretty low current, which is why the voltage drops are so low. A silicon diode would normally have more like 0.7 if you had any significant amount of current going through it. Alright, so I'll just tack this in place, and then let's give this another try. Alright, there's the signal on one side of the diode. Let's see what we've got on the other. Alright, that looks more like it. It's supposed to look like that. So, now let's try again. Over on this wave shaping coil. Yeah. Not really what it's supposed to look like, but it looks stable. Yeah, no significant dropout. Alright. About a frequency. Whoa, way off on frequency. 40 kilohertz. Turns out the horizontal hold on this set is really just the horizontal oscillator control. Just kind of a cheap way to do it. So, adjusting that now. Well, part of this circuit is feedback from the flyback, and I have the horizontal output tube disconnected, so I don't know that this will be particularly stable without that being connected. So I'm going to power this off and give that a try, see what happens this time around. Alright, so yet another power test, this time with the plate cap reattached. That's different. Ah, and the waveform on the scope looks right too. Now clearly there's something occasionally very unstable. Let's see where my voltage probe go. I know you can't see the scope, but trust me, it looks right in the frequency. It's off, it's 14.5. Ooh, I can smell something. Ooh, something's getting hot. It's getting a little stinky. resistor I replaced the 8.2K. It's pretty hot. And the two resistors at the front of the set are getting pretty freaking hot too, but they're both like 10 watters, and I know one of them is dissipating a full 10 watts, or maybe a little even a little more. Well, I'm going to try powering this up again because I want to check that high voltage. I'm just not going to leave it on for very long though. Doesn't necessarily mean anything's bad. I mean, these sets do get pretty toasty. It's just it's something I hadn't noticed before. So it's back on. Yep, we got high voltage. Not a lot, but the set doesn't need a whole lot. I know this meter's off a bit, so it's probably 8,000 volts or so. Well, I am going to put everything back together and try running this again. You know, put the CRT back in and all that. Oh, there's that burning smell again. Smells like it's kind of coming from down around in here somewhere. Well, I mean, well, I hate this. Ooh, could be that. Wow, that resistor's getting toasty. Yeah, I think that's what it is. Don't know what to do about it. I'm not sure what it means, but it's a power resistor. This guy. Some new one I put in there. In fact, it's getting hard to even read the bands. I think that was 270 ohms. That's what's that for? I was about to say one way to find out what's frying is just to let it fry and until it's obvious what it is. I think that was getting pretty close to that point. Maybe that's 20. Oh, I wonder if that's the problem. I think that might be this guy, which should be 2700. I think I had 270 in there. It's a little hard to tell now because it's getting a little charred and the color bands have changed color. Positive side. No, because that's on the negative side of that cap. Unless I put that cap in backwards. Oh wait, no, okay, that's the positive side. Yeah, I'm pretty sure that is that resistor. So, okay, that could be a little problem there too. So let me double check that value, and put the correct one in if I am wrong on that. Well, it turns out that I did have the right value of resistance in there. That was a 27 ohm. It turns out that I do have a 2700 ohm resistor in there. It's just discolored from frying, but I measured it and it still measures okay. So I went ahead and put the CRT in, and I'm sure that resistor is going to go up in smoke, but I want to at least see if we can get a raster on the CRT, so I'm still curious about whether or not it needs an ion trap magnet. The resistor that's frying is this guy, which is in the vertical output circuit, and it also goes down to the flyback area. And I think it's involved somewhat in the boost circuit too, so I guess it made sense that when the flyback wasn't running properly, it wasn't getting roasted. Now that it is, there's something not quite right in the circuit still, but let's hope it will last long enough that we can get a raster. Alright, so here it goes. Got the set unplugged? Yes, I do. signal source. Left the speaker disconnected. I'm using my test pattern generator. I'm not going to hear anything interesting out of that anyways. Okay, here we go again. Everything lighting up. No raster though, I just turned it off quickly. Alright, so let's see, brightness. It's third down. It wasn't up all the way, I could try that. Contrast is on the bottom side here. Okay, let's try this again. Nothing. Oh wait, oh. That yoke is way crooked. There's height. So, answer the question about the ion trap magnet. No, it does not need it. And turn that off. As the resistor starts to get toasty again. Okay, a few more observations. It seems like this capacitor is getting a little toasty as well, so no, I don't think it's in there backwards because the positive side is going to the 2700 ohm resistor, but it may have gone bad when there were other issues in this set, and I'll double check the wiring in that area. But something else that definitely confirms this thing has no ion trap when it was rebuilt. That's because there's a nice ion burn right in the middle of the picture tube. And the reason it takes so long for the CRT to light up is because what I said earlier, this is a 0.6 amp CRT and a 0.45 amp set. That's why the set's powered up now and there's still no image on the screen. I straightened out the yoke and adjusted the height a bit so it's a bit better now, and you will see, as it slowly lights up, there's a nice spot burn right in the middle of it. So, I guess I'll still continue restoring the set, but I suppose you could say that'll add some charm to the set. I don't know, but that's only going to get worse with time, so it gets a nice spot burn right in the middle. And that's with the set, the CRT running on reduced juice. I was going to alter the circuitry to get a proper 0.6 amps running into the CRT, possibly by even adding a little filament transformer in there somewhere. But if I do that, that's just really going to accelerate the burning of the phosphor on this. So I don't know what to do about that. I mean, well, there's nothing I can do. I mean, you use it, it's going to burn. There's absolutely nothing that can be done about it because this was rebuilt with a straight gun and not a bent gun. Anyway, so I'll focus now on dealing with that fried resistor and toasty capacitor. Well, what do you know? I do have that capacitor written backwards after all. I have the negative going down and tying into that fried resistor. It's supposed to be the positive side that goes to that resistor. I suspect what happened is that often on old capacitors they prominently mark the positive side, whereas modern caps prominently mark the negative side. So when I clipped out the old one, I probably saw that the indicators were going towards this direction, so I just put the new one in. That's what I get for working on these sets so late at night. And unfortunately, this was an axial cap, which are hard to find these days. That was probably my last one, but I'll dig something up and tack it in there and replace that resistor while I'm at it too. It turns out I did have a new axial 10 microfarad on hand, so I replaced that and put a new 2700 ohm resistor in there. Here's the old one, and if you're wondering how could this have worked at all, well, generally electrolytics will work to some extent when hooked in backwards. But it's probably suffered some damage. I'll hang on to it so I can maybe check it out with my LC53 capacitor analyzer when I get around to that. But right now, I want to try firing this up again. I got the speaker reinstalled and I'm using a converter box this time. So let's see what we get. Some nice scratches on the CRT too, I just noticed. This crud will clean off. Set off and straightened out the yoke. I just turned it back on. Boy, that thing sounds horrible when it powers up. So this really long delay would be completely eliminated, or at least greatly reduced, if this thing was running, if the CRT was running at the proper filament current. Alright, so that's weak over the air. Let's see if my converter box is on. Channel 3, it looks like. There it is. So right away it's I Love Lucy. Just in the fine tuning, it really doesn't have a whole lot of effect, as I noticed. Let's see, there's contrast. So it's there. It looks like the horizontal hold is just way out of whack. Try adjusting that. It's getting worse. Go the other way. Oh, there. Looks like we're at about 4 times the right frequency. Brightness down low. It's definitely an image of sorts.
Listen to a story about a man named Jed. The poor mountaineer fairly kept his family fed. And then one day he was shooting at some food, and up to the ground stumbled a big cruel. Black gold, Texas tea. Well, the first thing you know, old Jed's a millionaire. The kinfolk said, Jed, move away from there. Said, California is the place you ought to be. So
I just kept playing with those 2 controls back and forth, the waveform shape and the hold. Finally got it. The picture's not too bad, all things considering. Linearity's way off. There's a control for that buried inside the set.
Gee, I've been trying to call Mr. Mr. Drysdale, but ain't no answer at his house. Oh, he's been sleeping here, Uncle Jed. Ellie's beer shop.
So as far as the iron burn goes, well, it's right there, and yeah, once you know it's there, it's kind of noticeable. Well, for I'll just go with the CRT indefinitely. Eventually, may find the correct one. It's playing well enough. I don't think I'll bother going through and doing an alignment on it. Doing alignments on these hot chassis portable sets is really a pain anyways because it's so cramped. And I get good sounding, good video at the same point with fine tuning, which is the most important thing.
I think I'll transfer the buzz right now. Is that the way he's back yet?
And I can pretty much eliminate any buzz from the audio.
A rabbit's foot. Yeah, that's my insurance. Does it work? Ain't been robbed yet.
So let's see about that linearity.
With you folks been putting in so much money, I figured I better double the coverage. Yeah, I reckon a bank can't have too much protection. It sure is a dandy Buckeye. You got any more like this? I'm curing a whole bunch of them in the back room. Help yourself. Thank you. Oh, baby Granny'd like one, too. You would for a fact.
Mr. Grover, I have just had the most exhilarating drive through your charming village.
I'm glad you like it, Miss Hathaway.
Far the other
I
way,
understand that every Christmas you decorate the Hooterville Cannonball and ride to the valley singing Christmas carols.
Yeah, we've been doing that for years.
I can't wait to join in.
Good. Well, we'll be ready to
Need a test pattern generator to get it right for sure, but
from the old bank
it's
to the one
looking
Mr.
better.
Grandpa gave me.
I thought my boss was the only one who opened his bank on Christmas Day.
Oh, you're joking. He don't really.
He should be arriving at the office just about now. May I call and wish him a Merry Christmas?
Of course.
Merry Christmas, Mr. Drysdale.
Ah, I'm on. What are you doing in here? Can't you read? This is private. Now get back your bookkeeping.
Oh, Mr. Drysdale, your employees requested me to hand you this petition, asking you to let them go home and have Christmas dinner with their loved ones.
Most of those goofballs don't get any work done. They spend all their time signing petitions.
You didn't even read it.
I know it by heart. It hasn't changed in 20 years. Now pick up that mess, litterbug. And then go downstairs and tell those malcontents that they want something for Christmas. I'll give them a taste of the cat.
Exceptionally mean this morning.
alright, that's gonna be it for now. I'll tweak it a little bit more and then I guess put it back together. Glad it wasn't anything too serious. Definitely some unexpected twists and turns, but glad I got it running, that's for sure.
Now I won't accept the charge.